Please like, subscribe, and set alerts to be notified of the next video. Let's begin with an overview of the site itself. The property boundaries are highlighted in green. The watercourse itself works its way through the landscape roughly in this manner. The penstock will be 12 inches in diameter and approximately 1,230 feet in length. It will be buried along with an electric transmission line, which will carry the power to the control room. The head measurement of this system is only 36 feet, and the designed maximum flow rate will be for 3 cubic feet per second. Let's take a look at the intake area, where a diversion wall has been designed to direct the stream flow through a coanda screen and into the 12-inch penstock. The installation of this diversion was accomplished with a mini excavator. The stream bed is first compacted and can hold a non-permeable membrane. Then the excavator is used to position the southern section of the wall into position. I want to thank Ken Gardner and his crew for sharing all the time-lapse footage and still photographs which are used in making this video. You can see that the diversion wall was quite heavy and cumbersome to get into the proper position in alignment across the stream. In preparation for the remainder of the wall, the stream bed was raked free of any unevenness. The other section of the diversion wall, which contains half of the coanda screen, was then moved into position. With the remainder of the coanda screen installed, you can see the diversion pipe revealed under the water. Then, heavy fill material was placed on the downstream side. A non-permeable membrane was positioned at the far end of the wall. The water nearest the camera is blocked and the necessary fittings are installed and buried, with a 12-inch wafer butterfly valve then being connected, and the excavator goes to work filling in the temporary diversion of the water around the wall. This restricts the water outflow and channels the stream to its intended course, flowing over the coanda screen. The process is completed when the wall is fully weighted down with mud and rocks. Topsoil is also brought in, and a bit of gardening is done with the transplanting of native willows on both sides of the creek. Over time, this will serve to stabilize the wall's position within the water channel as a permanent fixture. With the stream flowing fully over the coanda screen, the 12-inch valve and an air vent have been installed. The diversion wall's design was planned for a potential future flood stage of up to 100 cubic feet per second. In that case, the water will flow over the remainder of the wall and still permit the diversion via the coanda screen. Heavy rocks have been placed in the flood section to ensure that they won't be washed downstream. By far the most time-consuming part of the system installation is the placement and burial of the 1,230 feet of PVC pipe. The pipe was laid out in preparation of the trench digging and burial. The white pipe has a lower pressure rating and is positioned at the outlet of the diversion wall. Great care is taken with a transit, which is off camera, and a measuring rod to ensure that the downslope grade of the penstock is properly maintained. Proper bedding of the pipe assures that when the trenches are filled, the rocks will not damage the pipe. Now let's take a close look at the business end of the penstock, where the Francis turbine will be situated. A metal discharge chamber, which has been prefabricated off-site, is positioned to discharge the water back to the stream bed. The Francis turbine, with an extended draft tube, is installed and bolted into this chamber. In a future video, we will discuss more about how this design functions to extract power from water and when it is the best choice for a microhydro system. Having the turbine in place, it is time to install a Z-pipe which will raise the water to do its work. A drain valve is an important element of the Z-pipe and will facilitate fully draining the penstock if ever needed. A second 12-inch wafer butterfly valve is positioned at this end along with a pipe to access the drain valve. As stated earlier, it is important to bed the penstock carefully, as you can see the crew doing here at the lower end of the pipe. They are using fine sand and clay particles both below and above the pipe for protection. Once bedded, a blue and silver warning tape is buried above the pipe to warn against any future intrusions that would damage the pipe. With this completed, the electrical 2-inch conduit is buried above the pipe with an additional red and silver warning tape to indicate its presence. Let's take a walk through from the intake dam where the Coanda screen filters the water, and we see that the 12-inch valve control and air vent have been painted. The upper section of the penstock will have the lighter pressure rated pipe buried, and as we progress down the line we can see both additional loads of bedding material as well as the 2-inch electrical conduit staged for burial. A transition is made to the blue higher pressure rated pipe, and we proceed to the ditch where it will be buried. Further on we see the blue and red warning tapes and eventually come to the end of the penstock where again we have a 12-inch valve control and a vertical pipe leading to the drain valve. The electrical conduit is exposed so that the wiring can be pulled via a fish tape at a later date. The lion's share of effort and also expenditure is involved in constructing the 1,230 feet of penstock. Care in its placement will ensure that it never needs to be repaired. The overall costs of an off-grid microhydro system require primarily upfront expenditures. The rod on the right is used to remove any debris from the inside of the pipe before it is assembled. A properly designed and installed microhydro system will continue to pay off for the life of the system. Connecting the final segments of the pipe near the headgate is accomplished with the use of a repair sleeve. Both sections of pipe are prepared for assembly and carefully aligned before being bolted together with numerous nuts and bolts. With this repair sleeve now securely in place, what remains to be done is the completion of burial, the pulling of wire, and the installation of electrical equipment in the control room. But this is where we will stop. My intention is to accompany the crew to film the remainder of the project. I again wish to thank the system designer, Ken Gardner, and his crew for their generosity in sharing all of this footage and allowing me access to share the documentation of this system. And thanks for watching and learning about microhydro.